This is section 4.2, and our first definition is a factor. Factors are numbers that when you multiply together you get a product, but a factor of a number n is a non-zero whole number that divides evenly into n. And the factorization of a number is the product of factors that equal n. So if we are looking for factorizations of 12, we're looking for what numbers can we multiply together to get 12. So 1 times 12, 2 times 6, 3 times 4, and 2 times 2 times 3 are all factorizations of 12. To help us find factors of numbers, we can look at divisibility rules. And we know a number is divisible by 2 if it's an even number, meaning doesn't end in 0, 2, 4, 6, or 8. Examples 26 and 384 are divisible by 2. A number is divisible by 3 if the sum of its digits is divisible by 3. So if we look at the number 312, and we add together the digits 3 plus 1 plus 2, we get 6. Since 6 is divisible by 3, so is 312. You can also look at 6 as being a multiple of 3. So if you add together digits and you get a multiple of 3, 3, 6, 9, 12, it's also another way of telling that it's divisible by 3. A whole number is divisible by 4 if its last 2 digits, the tens and ones place, is a number divisible by 4 or is a multiple of 4. So in these examples, 40 is 4 times 10. 16 is 4 times 4. So these numbers are divisible by 4. A whole number is divisible by 5 if it ends in 0 or 5. A number is divisible by 6 if it's divisible by both 2 and 3. Examples 90 and 456. A whole number is divisible by 9 if the sum of its digits is divisible by 9, or if the sum of the digits are a multiple of 9. For example, 72, 7 plus 2 is 9. 882, 8 plus 8 is 16, plus 2 is 18. That's a multiple of 9. And a whole number is divisible by 10 if its ones place digit is a 0. Okay, so here's an example, and we're going to determine whether 720 is divisible by the following numbers. So we know it's divisible by 2 because it ends in a 0. We know it's divisible by 3 because if we add 7 plus 2 plus 0, we get 9, which is a multiple of 3, so it's divisible by 3. If we look at the last 2 digits, 20, that's a multiple of 4, so it's divisible by 4. It ends in a 0, so it's divisible by 5. Because it's divisible by both 2 and 3, it's also divisible by 6. The sum of the digits 9 is a multiple of 9, so it's divisible by 9, and because it ends in a 0, it's divisible by 10. So next we're going to look at prime and composite numbers. So a prime number is a whole number greater than 1, and it has only 2 distinct factors, 1 and itself. A composite number is a number whose has at least 1 factor other than 1 and itself. 0 and 1 are neither prime nor composite. So if we look at the factors of 19, the only way we can get 19 is to multiply 1 times 19, and that makes it a prime number. The number 51, in addition to 1 times 51, I know this is divisible by 3 because when I add 5 plus 1 and get 6, it makes the number divisible by 3. 3 times 17 is 51. So in addition to 1 and 51, this number has 3 and 17 as factors, making it a composite number. 1, by definition, is neither prime nor composite. The prime factorization of a number is the factorization in which every factor is a prime number. The order does not matter. Is the product 2 times 3 times 10 the prime factorization of 60? Well, 10 is not a prime number, so it is not. 60 is 6 times 10, and 6 is 2 times 3. 10 is 2 times 5. So 2 times 2 times 3 times 5 is the prime factorization of 60. To find the prime factorization of a number, we can make a factor tree and we can just break the number down into its factors, and you can start any place you want. 22 times 10 is 220. This is 2 times 11. This is 2 times 5. So 2 times 2 times 5 times 11. When multiplied together gives us 220. This is the prime factorization of the number. The fractions 3/6, 2/4, and 1/2 all represent the same portion of a whole. So we call these fractions equivalent. We're going to determine whether two fractions are equivalent by taking the cross products test. If we multiply across 6 times 39 and 18 times 13, these cross products are both 234. If the cross products are equal, the fractions are equal. So we can use the cross products test to decide if we have equal fractions. So here I can multiply 7 times 7 is 49. 5 times 9 is 45. So these are not equivalent fractions. The fraction 1/2 is said to be in lowest terms because the numerator and denominator share no common factors other than 1. So to simplify a number to lowest terms, there's multiple ways, and you can also use a calculator to reduce this fraction. We can divide out any common factor. If you recognize that 2 is a factor of 6 and 2 is also a factor of 10, 2 divided by 2 is 1, and this fraction reduces to 3/5. What we've done is we've divided out a common factor. We can also use prime factorization. I can take 6 and break it down to its prime factorization, 2 times 3, and 10 is 2 times 5. And if I write the prime factorizations, you'll see that I'm also coming up with the same solution. So I'm going to use the prime factorization to break down 20 and 24 and then reduce the fraction. So 20 is 4 times 5, 4 is 2 times 2. So 2 times 2 is 4, times 5 is 20. 24 we know is 6 times 4. That's 2 times 3, 2 times 2. So 2 times 2 times 2 times 3. Now, 2 divided by 2 is 1. 2 divided by 2 is 1. And I'm left in the numerator with 5, and multiplying the numbers in the denominator, my fraction reduces to 5/6. The largest number that divides evenly into two or more integers is called their greatest common factor, GCF.